Happy Wednesday, everyone. Hope that you're having a good day up to this point. I'm not here today, obviously, as you can see. So what I want you to do is get out last night's homework assignment. We're going to go through that first, make sure you understood it. We'll go through every problem. We'll have to go pretty fast because I don't want to linger on this too long. And then here in just a couple minutes, you're going to get a review for a quiz. I'm going to go through some of that review, and then afterwards, there are some questions that I want you to complete tonight. Now, the quiz is not going to be tomorrow. Tomorrow when I come back, we're going to go through all of the problems, make sure you guys are clear and understanding of all this stuff, transformation, and then we're going to take the quiz on Friday, okay? So that is our plan for the rest of the week. But first, let's go through this worksheet that you guys had for homework last night. Now, again, I'm not going to spend a lot of time, but if you have questions along the way, and I'm going through these too quickly, please make a mark on your notes or on your homework and talk to me about it when I come back to school tomorrow. So let's get started. So the first problem that we have here, as you can tell, the only transformation that we see is adding, which is a shift. It's inside the absolute value bar, so it's horizontal. And we know that with horizontal shift, it always does the opposite. So that looks like a positive 5. So it's actually a negative 5 horizontal shift. So we're looking for the one that shifted to the left 5. And that is right here. It shifted to the left 5. So it has to be B. Okay, number 2, we got the same thing happening. It's adding 5, so it's a shift. But where is it? Well, it's outside. It's vertical. Well, vertical is what it is. So this thing should have gone up 5. The one that goes up 5 is right here. So this definitely is C. Number 3, also 5. However, it's subtraction, still a shift, but inside it means horizontal, and we know it's the opposite. So if it looks like negative 5, it actually goes to the right 5. So it has to be this one. It went to the right 5. So we got D for number 3, which leads us to the last one, which we already know which one it is. We're subtracting 5, which is a shift. It's outside, so it's vertical. It is what it is. So this one's going down 5. Clearly, that's the one A that went down 5. So it's B, C, D, A. All right, let's keep on cruising along here. For the next several problems, and again, remember I told you to eliminate F on both problems. So you had 5 here that you were supposed to describe the transformations. So here we go. This one has one thing. It's subtraction. So it's a shift. It's inside. It's horizontal. It's the opposite. So this is a positive 3 horizontal shift. So this one is going to shift right 4. Or I don't know why I said 4. 3. It's going to shift to the right 3. All right, B over here to the right. What's that 5 doing when it's out front? Well, we're clearly multiplying. Multiplying is a dilation. Well, it's outside, so it's a vertical dilation. Vertical dilation. So try to picture this in your brain. Now, the fact that it's greater than 1 means it's going to become more narrow, right? So which vertical dilation makes it more narrow? A vertical stretch or a vertical compression? Well, this is definitely a vertical stretch. Okay, C. We're back here to adding. Adding, of course, means it's shifting. It's outside, so it's vertical. It's a vertical shift. So this thing is going to shift up 7. And the next one, we've got 2 things going on. Let's start right here. What is that negative out in front telling me? Well, that negative out in front is saying, hey, this is a reflection. Well, it's outside, so it's a vertical reflection. So hopefully you guys recall, vertical reflections reflect over the x-axis. But that's not all we have here. We also clearly have adding 4. That's going to be a translation or a shift. It's inside, so it's horizontal. It's inside, so it's opposite. So this is going to be a negative horizontal shift. So this thing's going to shift left 4. All right, and then that brings us to the last one here on this group. We've got a 1/2 that we're multiplying by. So multiplication tells me it's a dilation. 1/2, inside tells me it's going to be horizontal dilation. 1/2 being less than 1 is telling me this graph is getting wider, okay? It's getting wider. So I want you to think about your two movements with horizontal dilations, okay? Which one makes it wider? A horizontal stretch or a horizontal compression? Definitely a horizontal stretch. But don't forget, we also have this other thing happening. It's adding 4. Adding, of course, is a shift, a translation. It's outside, so it's vertical. It's outside, so it does the opposite, it does what it looks like it's doing. So what is a positive 4 vertical shift? It shifts up 4. All right, and there was A through E of number 5. Now let's go to number 6, and let's talk through A through E on this one. All right, first of all, we got a negative. That's a reflection. It's inside, so it's horizontal. So this thing is going to reflect horizontally, which means it reflects over the y-axis. Next, we got this problem adding 2. Okay, adding is a translation, a shift. It's inside, so it's horizontal. It's inside, so it's the opposite. So it's actually a negative 2 horizontal shift. So that's going to shift negatively, right? Left 2. And then finally, we also have this -8. Well, -8 is clearly on the outside, so it's shifting still, but it's shifting vertically. And vertical is what it is, so this thing is shifting down. It shifts down 8. All right, C. C has 3 things, so we got a lot going on here. First, we got the negative. Again, as soon as you see negative, you know it's a reflection. It's outside, so it's a vertical reflection. So this thing's reflecting over x-axis. Okay? Next, we got this -3. Okay, that's shifting. It's inside, horizontal. It's the opposite. So it's a +3 horizontal shift. So it shifts right 3. And then lastly, we got this +2. It's shifting. It's outside, so it's vertical. It is what it is, so it's up. So it shifts up 2. So a lot going on there, okay? Make sure you don't get lost in all those words. Okay, next one. We're going to start with that 3/2 that I'm doing what to? I'm multiplying. I'm multiplying. So I know it's a dilation. Where's it happening? Inside. It's horizontal dilation. So imagine this, y'all. You're horizontally stretching or compressing. Try to imagine the motion you're making here. What about 3/2? Is it greater than 1 or is it less than 1? Well, it's definitely greater. So this thing has to get more narrow. It has to. So think about those two motions horizontally. Does a horizontal stretch or does a horizontal compression make it narrow? A horizontal compression. Okay, last thing on this problem, you have this +1. That +1 is telling me it's a shift. It's outside, so it's vertical, and it is what it is. So this thing is shifting up 1. All right, last one for your homework last night, and I hope that you guys got every one of these right. If you did, I'm impressed. First, we're multiplying by 4. So it's a dilation. Where is it? It's outside. It's vertical. It's a vertical dilation. So I want you to think about vertical dilations. We talked about those. Now, this one is clearly greater than 1. And if it's greater than 1, like we just said, it has to get more narrow. So think about your vertical dilations. Are you picturing it? Which vertical dilation makes it more narrow? A vertical stretch. Again, if you got that wrong in your brain, try to picture it. If I vertically stretch it, it's going to narrow it. And then the last thing here we have is minus 2. We're subtracting. We're subtracting. Subtracting is a shift. It's inside, so it's horizontal, left to right. It's the opposite, so it's a positive 2 horizontal shift. So this thing's shifting to the right 2. All right, so maybe you got every one of those right. If you did, awesome. If I missed one, I guess it's possible. I've made mistakes for sure in the past before, so I wouldn't put it past me. If I did, then definitely point that out to me tomorrow. All right, we're going to move along. Don't throw that paper away. Hold on to it. But we're going to now move along to this review. If you haven't gotten it already, I'm sure that it's kind of making its way to you right now. So in this review, we're dealing with not just transformations, but we're dealing with all of these key features of functions that we've been talking about recently. All right, so I'm going to go through this relatively quickly. You're going to have some examples for you to do tonight, and we're going to have some time to talk about this tomorrow. Make sure you guys are all in a good place going into our quiz on Friday. So first of all, domain. Now look, domain is left and right. Does this thing ever stop going left? Does it ever stop going right? Of course not. So my domain is unlimited. What do we call unlimited? Negative infinity to positive infinity. Now, look at the range. Does this thing ever stop going down? No, look, they're both arrows downward. But does it ever stop going up? For sure. It stops going up right here. It will never go above that point. Now listen, if I'm naming these, I always name them from small to big. Well, we said it's going down forever. So it's going towards negative infinity, down. But up, it never makes it past 3. So I have to use a bracket. Remember we talked about that? We use a bracket to indicate that we're never going to make it all the way there. We're never going to make it past it. We stop right on 3. Okay? Now, two really simple concepts. X-intercept is here and here. I'm going to name them full ordered pairs. So that's negative 2, 0, and that's 4, 0. My y-intercept, of course, a little different. My y-intercept is right here. And that's not 2, 0. That's 0, 2. Okay? Now, along the same problem, and they just made another graph just so you could picture it. We're talking about our increasing intervals. Now remember, this is as we're reading this graph from left to right, as we're going from left to right, we're naming the place where it's increasing or decreasing. So I want you to picture this graph right here that we're looking at. When I run into it right off the bat, what's it doing from left to right? Well, it's clearly going up. Now, how long has it been going up? Well, that's an arrow. It's been going up from as far to the left as possible. Well, how do I call as far to the left as possible? I call it negative infinity. Right? I call it negative infinity. And then, what does it start doing? Or how long does it increase? Well, it increases up here to this point right here. But remember, when we're naming intervals, we're talking about from left to right. So we care about this value right here. And sometimes this thing is misbehaving. But it won't increase past 1. It's increasing as it approaches 1. And then what does it start doing? Well, clearly you can see from left to right, it starts decreasing. And how long does it decrease? Forever. It decreases forever to the right. So our decreasing interval is from from positive 1 to positive infinity. All right? Same graph. We're talking now about positive and negative intervals. Remember, positive and negative intervals is all about one concept. Where is it above this x-axis? Where is it below it? So if I think about above, well, it's definitely above it from here to here. Now remember, when we talk about this, we're talking about the specific places where it's crossing the x-axis. This is the whole region right here where it is positive, okay? From -2 to +4. That is the interval where this thing is above the x-axis, okay? Now, what about where it's negative? What about where it's below? Well, it's below all through here. See, look, all of this is below, and all of this is below. So how do I name those? All right, well, we name them from left to right, so let's do that. Where am I coming from the left? Well, I'm coming from an arrow. That's from -infinity, and it stays in this negative area until it gets right back here to the same x-intercept, -2. Then we already talked about it being positive for a while, and then it goes back into the negative world forever from +4 to infinity. Now look, not down, not -infinity, but right, +infinity. Okay, we always name our intervals from left to right. Okay, so don't think down, think right. And there you have it. Okay, pretty simple. Let's go through this one. Very similar. Domain. Well, it never stops going left, never stops going right, so -infinity to +infinity. Range is a little different this time than the last because this time it never goes past this y value. Now, it goes up forever, doesn't it? So my range, the bottom part of it is -4. But it goes up towards +infinity forever. Okay? So there's your domain and range. Of course, x-intercept's real simple. That point is -7, 0. And this point right here is 1, 0. And your y-intercept is right here at 0, -1. Very simple. Okay, I expect you guys can do domain, range, x-intercept, y-intercept without any real problems. Okay, increasing. Again, from left to right, clearly, it's going up from here on. Well, what x value did it start doing that from? Right here at -3. And it increased forever to the right. Forever to the right. Okay, let me erase that real quick because I got a little messy. Where's it decreasing? Well, it's definitely decreasing right here from left to right. So that was forever this way, all the way, well, man, this thing's getting out of control, all the way till this point right here. So that's from -infinity back to that same value of our minimum of x, -3. Okay, right here. This is the place where it stops decreasing and it started increasing, -3. All right, so there's your increasing and decreasing. Last thing, your positive and negative. This one's a little different from my last one too because it's positive all up in here and it's positive all up in here. And it's negative all down in here. Now remember, we're talking about our intervals. So where did it start being positive? All through here. So that's from -infinity to this x-intercept, -7. Then it went down into the negative world from -7 until it got to this x-intercept, 1. And then finally it went back up into the positive world from 1 forever. So there you have it. These are all terms that at this point you should be very familiar with, and maybe you're not a pro at it yet, but you should be getting better. All right, transformations. Now, I'm not going to fill these transformations all back inside slowly and talk about it for a long time. I'm just going to fill them out real fast. So don't forget, when we're adding inside, we are shifting. It's the opposite, right? So it's going to be left H. When it's subtracting inside, it's the opposite. It's shifting right H. Okay? Outside's vertical, so if it's positive K, it's up. Okay? And if it's down, or if it's negative, it's shifting down. Pardon my handwriting. I feel like it's a little sloppy. I'll do better on the next group. Okay, next. When I'm multiplying outside, it's vertical. When I'm multiplying inside, it's horizontal. But the focus also needs to be right here. If the A value that you're working with is greater than 1, it's got to get more narrow. So that's both of these two. And then if that value is less than 1, it's getting wider. Now, if I can remember that, it's going to help me to be able to picture these things. So first, if it's multiplying outside, we know it's a vertical dilation. Well, what vertical dilation makes it more narrow? Well, that's a vertical stretch. And then the vertical move that makes it wider, that's going to be a vertical compression. It's smashing it. Okay? Now, remember, it's greater than 1, so it has to get more narrow. So when I think about multiplying inside, and I know it's a horizontal dilation, which horizontal move makes it more narrow? Well, that's definitely a horizontal compression. Think about it. Picture it. A horizontal compression makes it more narrow. And then what move horizontally makes it wider? Horizontally stretching it. Okay? And then the last two are all about negatives. If negative is outside, it's a vertical reflection. If negative's on the inside, it's a horizontal reflection. A vertical reflection reflects over the x-axis. But a horizontal reflection reflects horizontally, meaning over the y-axis. And there you have it. Those we talked about yesterday and the day before. So let's name these, and I'm going to be done with you. We're at about 23 minutes or so, so you're going to have some time to work on your assignment. But let's go through these last 13. I don't think there's any we need to eliminate. No, there's not. So here we go. First, we're subtracting 1. What does that mean? Well, it's a shift. It's outside. It's vertical. It is what it is. A negative vertical shift means it shifts down 1. Okay, look at the next one. This one is subtracting 3. It's a shift. It's inside. It's horizontal. It's the opposite. It looks negative, so it's actually a positive horizontal shift. A positive horizontal shift is shifts right 3. Okay, let's move to the top. We got two things going on here. One, multiplying by a negative. Where is it? Outside. That's a vertical reflection. Vertical reflection means it reflects over which axis? X-axis. But we also got plus 6. That is a shift. It's inside, so it's horizontal. It's the opposite. So that's actually a negative horizontal shift. So it shifts left 6. Number 4, multiplying by a negative, right? We're multiplying by a negative. Let me use a different color just so we don't run into stuff. We're multiplying by a negative. It's inside, so it's a horizontal reflection. A horizontal reflection means it reflects over the y-axis. It's horizontal. And then finally, we're adding 3. Where? Outside. That's a vertical shift. It is what it is, so that's a shift up 3. All right, next. We're multiplying by 4. That's a dilation, multiplying, right? It's outside, so it's vertical. It's a vertical dilation. Picture this thing, y'all. Think about the 2 directions. You could pull it up or push it down. That's vertical dilations. Well, this value is 4. That's greater than 1. It has to get narrow. Which vertical move makes it narrow? A vertical stretch or a vertical compression? Definitely a vertical stretch. And then lastly, on this problem, we're subtracting 2. That is a shift. It's outside, so it's vertical. It's negative, so we go down 2. So this thing shifts down 2. All right, number next. We've got multiply by 1/2. So that's a dilation, right? It's outside, so it's vertical. Vertical dilation. We just did one of those. However, this one is a 1/2. So we're multiplying by a number less than 1. So it's got to get wider. So think about this, y'all. Vertically. What vertical move makes it wider? A vertical compression. I hope this is starting to make sense to you. Picture it. Okay, picture it. When you take your quiz on Friday, picture it. We're adding 5 as well. That's a shift. It's inside. It's horizontal. It's the opposite. So left 5. It shifts left 5. All right, number 7. This one's got 3 things going on. They're getting bigger and bigger. So this one we're multiplying by 4 outside. That's a vertical dilation. A vertical dilation. It's greater than 1, so it's got to get narrow. That's a vertical stretch. Then we're subtracting 2. That's a shift. It's inside, so it's horizontal. So this thing is doing the opposite, so it's shifting to the right 2. And lastly, we're adding 8 where outside it's a vertical shift. It is what it is. So this thing is going up 8. Okay? Last one on this section. We got a negative out here. That's a reflection. It's vertical. So that one's going to reflect over x-axis. Then we've got this multiplying by 5 here. That's a dilation, but it's inside, so it's horizontal dilation. Horizontal. Now, 5 is greater than 1. It has to get narrow. What horizontal dilation makes it narrow? A horizontal smash, a horizontal compression. I hope you're starting to picture these, because if you can see it, it's a lot easier to answer. Last, subtracting 1, that's a vertical shift. It is what it is, so it shifts down 1. Okay? All right, last one. This is just the same thing. It's just dealing with a quadratic. Your parent function's a quadratic. So anything, if you look through these, anything that's not x squared, anything that's not x squared, anything that's not x squared is a transformations. Okay? Anything that's not x squared is a transformation. So let me erase that so you understand. The squared is part of the function. So what is the different? Well, multiplying by 2. That is a vertical stretch. We'll go a little faster. We're adding 1 inside. That is a shift to the left 1. Whoops. Next, we've got minus 3 inside. That is a horizontal shift. So this thing shifts right 3. Then we're also adding 5. That's a shift. It's on the outside, so it's vertical, so it's shifting up 5. Next, we've got a negative. That's a reflection. It's definitely outside because there is no parentheses. So this thing is a vertical reflection, or we say it reflects over x axis. But we also are subtracting 6. Again, there are no parentheses, so it has to be outside. So that's a vertical shift. So it shifts down 6. All right? Next, we're multiplying by 0.25. Again, multiplying tells me it's a dilation. It's outside, so it's vertical. And it's less than 1, so it's wider. What vertical dilation makes it wider? Vertically stretching it or vertically compressing? Definitely vertical compress. Okay, and then we're subtracting 7. That's a shift. It is inside, it's horizontal. It's the opposite, so it's a positive 7. So it shifts right 7. And then lastly for this problem, we've got minus 9. So that's another shift. It's outside, so it's vertical. So it shifts down 9. All right, last one, and then I'll leave you to it. You're multiplying by 2. There are no parentheses, so it's clearly outside. So this is a vertical, what? It's greater than 1, so it has to get narrow. So which dilation makes it more narrow? Vertical stretch or vertical compression? Definitely a vertical stretch. And then last thing, plus 1. We're adding 1. Well, that's definitely outside. It's vertical. And it's shifting, so it's a shift up 1. All right, so listen. We've gone through all this stuff. This is all kind of review. Not kind of, it is review. So your assignment is to do these final problems, 14 through 26, and that is your homework. Your homework. All of these are doable. There's none that you need to eliminate. So tomorrow, when I come in, we'll answer any questions that you maybe had over previous homework. We'll answer any question you had over what I went through on this review, and we'll go over any questions that you have on this assignment. Then on Friday, we will take our quiz. All right, I hope y'all have a great Wednesday, and I'll see you tomorrow.